Welcome fourth graders to lesson 3-9. In today's lesson, your learning target is to make predictions using generalizations. And you might be thinking to yourself, wait a minute, we've done this before. And you'd be right. We've been introducing you to different generalizations all throughout the unit so that when this lesson came, you'd be well prepared to do it. So, I brought some company with me this time, and we are all set to remind you on how we go ahead and make predictions using our generalizations. Hope you're ready. This first one should seem very familiar to you. When you're multiplying a whole number by a fraction less than 1, we know that the product will be greater than the fraction and that the product will also be less than the whole number. So, quick example, 6 times 3/4. We know that without having to solve, that x will be greater than 3/4 and that x will be less than 6. When we go back and compute it or solve, we find that is 6 over 1 times 3/4, and now we know we can cross cancel that. So we end up with 9/2, which is the same as 4 and 1/2. And 4 1/2 is greater than 3/4 and less than 6. Here's another one that I'm sure you're going to handle just like superstars. And that's what happens when you multiply two fractions that are less than 1. You know that the product is going to be less than both factors. So if I have 5/8 multiplied by 1/4 being equal to n, without having to solve or compute, I know that n will be less than 5/8, but n will also be less than 1/4. And we know that that is because when we are multiplying, we are finding part of the other factor when we're multiplying by fractions less than 1. So when we read the equation as it is, 5/8 times 1/4, we are finding 5/8 or part of a fourth. So part of a fourth has to be less than a fourth. The commutative property tells us that that's the same thing as 1/4 times 5/8, which would be read 1/4 of 5/8, so part of 5/8, so it's also less than 5/8. Multiplying two fractions less than 1 means the product will be less than both of the factors. This generalization is a little bit newer, but it actually is a lot like the first generalization we looked at. In this generalization, we're seeing that when we multiply a fraction less than 1 in a mixed number, that the product will be greater than the fraction, but it will be less than the mixed number. So an example of that might be 1/3 times 2 1/4. But how does that relate to the first example that we saw? Well, imagine that it was 1/3 times 2. When you saw that, you'd know that if we were looking for a value x, that x would be greater than 1/3, and that x would also be less than 2. But compare that to the equation at the top. We still have the first factor being something that is less than 1, and the second factor is a factor that is greater than 1. Whenever you're multiplying two factors and one of them is a fraction less than 1 and the other one is a value greater than 1, the product will be greater than the fraction but less than the other factor that was greater than 1. So even though now, when we look at the top example again, we have a mixed number, we still know that if we were looking for x, that x is still going to be greater than 1/3, but it will be less than 2 1/4, even though it's a mixed number and not a whole number. And that's because, just as before, we can read that as finding 1/3 of 2 and a fourth. We're finding part of 2 and a fourth. So part of 2 and a fourth has to be less than 2 and a fourth. But it's greater than a 1/3 because 1/3 is being repeated twice and 1/4 more. So now when we look at multiplying two mixed numbers, we can just think of mixed numbers as being values greater than 1. And we already know that when we multiply any two values that are greater than 1, the product's going to be greater than both factors. So if I have 2 times 3 is equal to n, you know that n will be greater than 2, and n will also be greater than 3. Because 2 is being repeated 3 times, or 3 is being repeated 2 times. Well, multiplying mixed numbers is no different. If I take 2 and turn it into 2 and 5/8, and 3 and multiply that, or turn that, into 3 and a fourth, well, I still have two factors that are greater than 1. And whenever we have two factors that are greater than 1, the product will be greater than both factors. Just as in the equation above, n was equal to 6, so it was greater than both factors. Here, n will also be greater than 2 and 5/8, and n will be greater than 3 and a fourth, because we are repeating 2 and 5/8 3 and 1/4 times, or we're repeating 3 and 1/4 2 and 5/8 times. Factors are repeating, so they're going to have to be greater. So it should be no surprise that when you are multiplying a mixed number and a whole number greater than 1, that the product will be greater than both factors. It's for the same reason that was the case in the last generalization. A mixed number and a whole number greater than 1 are both values greater than 1. So if I have 2 and 3/4 times 4, and I'm looking for, say, n again, n will have to be greater than 2 and 3/4, and n will be greater than 4, because multiplying means repeating factors. And 2 and 3/4 times 4 can be thought of as 2 and 3/4 repeating 4 times. And if we are doing repeat addition, of course, adding that together 4 times would have to be greater than what it is by itself. And even if we reverse and use the commutative property, it's also the same as 4 being repeated 2 times and then 3/4 more. So it's finding 4 times 2 and 3/4 times 4 also. And that would be greater than 4. Now, this generalization is a little bit new, but don't be scared. I think you'll pick it up pretty quick. And this is what we do when we are multiplying fractions equal to 1 by any factor, whether it's a whole number or a fraction or a mixed number. The product is going to be equal to whatever the other factor is, the other factor that is not a fraction equal to 1. So what does that look like? What do I mean? 4/4 is a fraction that is equal to 1, as is 3/3, so is 5/5, and we know they're equal to 1 because anytime the numerator and denominator is the same, that's a fraction that's equal to 1. 4 out of 4, 3 out of 3, 5 out of 5. It is all of the parts to make up the whole. So if I'm multiplying 4/4 by, say, 2, or 3/3 by, say, 1/8, or 5/5 by 3 3/4. In all of these situations, if we're looking for n, well, n is going to be equal to here 2, n is going to be equal to an eighth, and n will be equal to 3 3/4. Whenever you are multiplying any factor by a fraction is equal to 1, then the answer is going to be equal to that other factor. Just as if we were multiplying 1 times 4 would be equal to 4, because anytime we multiply a factor by 1, it's equal to the other factor. It's still the same if we're using a fraction to represent 1. Okay, it's now your turn to give some problems a try. Over here on the left, you can see there are 3 equations, and then on the other side is a variable and then a space for you to write greater than, less than, or equal to. I want you to decide if the answer to each of those equations is greater than, less than, or equal to each factor. You don't need to compute the answer at this time. I don't want to know what the exact answer is. I simply want you to predict the outcome. Give it a try. Okay, we can go ahead and check your work. In the first situation, we know n will be greater than the fraction and less than the whole number. In the next situation, n is going to be less than both factors, less than both fractions. And in the bottom, we have that x, rather than n, will be greater than 6/10, but it's going to be less than 2 1/4. Let's go ahead and try 3 more examples. Again, pause your video and try to predict the outcome in each of these situations. Please figure out whether or not the product would be greater than, less than, or equal to each factor. Pause your video now. Okay, let's go ahead and check your work. So in the top equation, x is going to be less than 8/8, but it's going to be equal to 2/5. Here, it's going to be greater than both factors, because both factors are greater than 1. And that is the same situation as we find down at the bottom. I do want to call your attention to one of the examples from the last screen, 8/8 times 2/5. Now, we found that n was actually going to be less than 8/8, but it was going to be equal to 2/5. And the reason that n was going to be less than 8/8 was because the other factor was less than 1. So it was going to be less than 1, less than 8/8, which is 1. But if I changed that to 8/8 times, say, 3, well, in this case now, n is going to be greater than 8/8, because the other factor is greater than 1, or greater than 8/8. But n would still be equal to 3. And if we have 8/8 again, but this time multiply it by a mixed number, like 2 1/5, then n is going to still be greater than 8/8, because the other factor is greater than 1. It's greater than 8/8. But n would still be equal to 2 1/5. Okay, everybody, that's it for today. I'm looking forward to seeing you all tomorrow in class, and be sure to bring any questions you have. See you in the morning.